us more about what the space station is and what it's accomplished so far?
Sure, Gary. Over those 20 years, we've conducted over 31 countries. The work going on the space station is not only there to help us with our exploration into space, but also to bring back benefits for Earth and to produce a commercial marketplace in low Earth orbit. All three of these objectives, along with the international cooperation that it took to build such an amazing laboratory in space, are great examples of the objectives of the ISS program.
Kurt, we know that today's mission is critical to providing us with a steady cadence of operational flights. But why is it so important for us to have this capability from a research perspective?
That's a great question. Today's test flight brings us to the beginning of the commercial crew program, a commercial crew program which will raise our occupancy on the U.S. segment of the space station to 4 astronauts. And that 4th astronaut comes as a real premium to doing research on the space station. The tasks don't get particularly more intensive to do systems and maintenance, so that 4th astronaut, that time becomes dedicated to performing more science. In fact, enough time that it will essentially double the amount of crew time we have to perform experiments on board station. The return to U.S. soil also brings us the ability to return samples more quickly and get human samples back down to the ground more quickly as well.
Kurt, you're talking about all this great research, you're talking about scientific experiments, but what would you say to someone who's watching this and thinking, this isn't relevant to me, I'm never going to space, I don't do science? What do you say to those people?
Well, again, one of the focuses is on the ISS benefits for humanity. And for all of us who've been stuck at home during the COVID-19 pandemic, we've been wondering, wouldn't it be nice to have more bandwidth? Why does the internet slow down? Some of the research we're doing on board space station, particularly into Z-band optical fiber, is using the fact of a microgravity environment to develop new materials that will help us build more perfect fiber optic cables, which will allow us for better bandwidth and lower cost in implementing networks here on Earth. And then if you're not really a tech geek, maybe your interests lie more in human health. And then we have multiple experiments going on to help us develop new drugs, new treatments on board the ISS. Pharmaceutical companies are working on methods that allow us to crystallize proteins in space in a more purified and more standardized method. And this could lead to monoclonal antibody suspensions that we can treat through injection instead of a painful infusion. We also are developing studies into our capability to produce tissues and organs in space. Again, because you don't have sedimentation, there's a capability there to produce more realistic tissues that can someday possibly be used to prevent human disease.
Now, Kurt, I know they have some cargo going up with them, but I understand they plan to bring some science back.
That's right, Gary. A lot of their cargo going up with them are crew supplies and EVA supplies to support them if they have to do EVAs on board. But the cargo they'll be bringing down is science, and it comes from across the spectrum. We have student experiments in seeds that will be returning with the Crew Dragon. We also have a number of experiments that are dependent on their samples returning in frozen lockers on board the SpaceX Dragon to be able to do the science there. Those include rodent research tissues from the National Lab Rodent Research 17 mission, and also our veggie experiments, which are experiments in growing plants in space that will be needed when we go to more distant locations like the Moon and Mars.
International Space Station Chief Scientist Kurt Costello, thank you so much for your time. Let's hear now from one of the next astronauts to fly to station.